Hey guys, this is a video about instantaneous rate of change. So, okay, here we have a parabola, y equals x squared. So I just sketched it. And let's say we want to eventually find out the instantaneous rate of change when x equals 3. So we know that in a parabola like this, the slope is always changing, the rate of change. It's always changing all the way around the curve. So when you have a curve like this, you know, the slope down here will be 0, and then it's going to start increasing. Our slope's just getting bigger and bigger. And on this side, our slope's negative and increasing. So we know our slope's constantly changing, but we want to be able to eventually find the slope at one exact point. So we talked about just picking, like you need 2 points to calculate the rate of change. So we talked about picking another point here, Q, and getting a secant, which is just a line between 2 points, and we can use that to calculate the average rate of change. And then we also talked about shrinking the interval between P and Q to be as small as possible so that we get a better approximation for the instantaneous rate of change. Okay, so let me just get rid of Q. So let's figure out what is our point P. So when x is 3, what is y? So if we sub it into our equation, 3 squared will be 9. So our point right there is 3, 9. So let's say we took another point, so let's call it point Q, and let's make it 3.1. So then our y value is going to be 9.61. And let's see what our rate of change would be. So we'd have 9.61 minus 9 over 3.1 minus 3. So our rate of change will be 6.1. Okay, let's try using a closer pair of points. So we'll still use 3, 9 because that's what we want to find. And this time we'll pick Q to be 3.01. So what's 3.01 squared? 9.0601. So let's figure out what will our rate of change be now. So if we subtract our y's from each other and divide it by our x's subtracted from each other, now we'll get 6.01. And then let's do one more. So let's keep our point 3, 9, but let's pick a Q value that's even closer. So why don't we pick 0.001? So 3.001 squared will be 9.006001. I'm keeping all the decimal places. Any guesses what our slope is going to be? Um, 6.001. So what does it look like if you examine all these values? We got 6.1, 6.01, 6.001. What does it look like our instantaneous rate of change is approaching? Like, to me, it looks like if I'm estimating what the slope is going to be right at point P, what is the tangent to the curve going to be right there? I'm thinking our rate of change right at point P is going to be 6. It seems to be what all of those values are increasing or are approaching. Okay, so here's a way that we can do instantaneous rate of change from our the equations that we learned in the previous video. So we talked about using instead of like a point Q at a specific point, like these 2 points, we talked about like picking a value 3 plus h and using that kind of point until we make h a really, really small number, like 0. Okay, so let's say we have the point P at 3, 9, And then we're also going to pick a point Q. And I'm going to say Q is going to be 3 plus H, some random amount. So like it could be 3 plus 0.00000001. And then our Y value is going to be whatever 3 plus H squared is. Since the equation is Y equals X squared, to get the Y value, we just square X, which is 3 plus H squared. Okay, so now we're trying to find the rate of change between those 2 points. So let's try to find the instantaneous rate of change this way. So we take our Y value of 3 plus H squared, subtract our other Y value, take our X values and subtract them. And let's just expand that bracket. So 3 plus H squared is going to be 9 plus 6H plus H squared. If we expand that binomial, minus 9 divided by 3 minus 3 is going to go away, so we just have H on the bottom. I notice on the top the 9s are going to cancel out, so we just have 6H plus H squared divided by H. So if I keep simplifying, I'm noticing that they all have an H, so I'm actually going to factor out an H on top. And then, because I can, I'm going to cancel the 2 H's, and I'm just left with 6 plus H. Now, I don't know if you remember seeing in the video yesterday, but we talked about, like, as H approaches 0, like we talked about limits. So what we really want is we really want this, this distance between P and Q, the X values, we really want that to be 0 because then we'll be right at point P. So basically we're just saying as the X values decrease, like the distance between them decreases, so they're right on top of each other, that's when we're going to get the best approximation for the slope right at point P. So as H approaches 0, then it looks like this situation right here, 6 plus H, is going to approach 6, right? Because if you throw in, as H becomes closer and closer to 0, this equation is getting closer and closer to 6. So that's when we can say stuff like, I know it's a bit confusing, but as we can now say, like, as the limit as H approaches 0 of 6 plus H is equal to 6. So it's just basically saying that as H is getting closer to 0, this equation here, 6 plus H, is going to be 6. And we saw that in the average rate of change. We saw it was 6.1, 6.01, 6.001. So it's approaching 6. So as that Q value, as it gets closer and closer to P, that's the value it's approaching. So that's how we find the slope at one point. We pick these values that get closer and closer to the point that we want. And the best way to do that for now is by making this second X value the first one plus H. Because then we can just restrict H to be nothing eventually. So basically we just found out that the instantaneous rate of change is 6 at point P. So let's try another question like that. Okay. So we've got an equation, f of x equals negative x squared plus 4x plus 1. This one's like a little trickier because it has 2 x's in it. Okay, so let's just say we want to find at x equals 3, we want to determine the slope of the tangent. Slope of tangent, which is another way of saying the instantaneous rate of change. And we're going to pick a random point of x equals 3. We could have picked 2, 1, 7, doesn't matter. Okay, so first let's figure out our first point. So we know we've got a point at 3 something. So let's sub in 3 and figure out what is f of 3. It is, let's just put 3 in. So negative 9 plus 12 plus 1. So 4. So we know that we have a point at 3, 4 so far. And we want to figure out the exact slope of the tangent right at point 3. So that means we also need to find another point, and that other point is going to be 3 plus h something. Okay, so let's use our limit equation that we kind of know. So to find the slope, we'll just call it m for now. We're going to say we're looking for the limit as h approaches 0. And I'm just going to write the original equation, f of a plus h minus f of a divided by h. Because you know that when you subtract your x values, the a plus h minus a, the a's are just going to cancel out and leave you with the h. Okay, so that's the equation we're working with. So I guess this is like our f of a here, so 3. So we need to still figure out what f of 3 plus h is. So why don't we do that over here? So f of 3 plus h is going to be equal to, you know what, actually I need more space. So that's going to be a little tricky. Okay, so why don't I just move that down. Okay, so let's figure out f of 3 plus h first. So basically everywhere you see an x, you're going to replace it with a 3 plus h. So it's going to be negative, and then instead of x, we're replacing it with 3 plus h. Just like in this one, we were trying to find out what f of 3 is, we replaced all the x's with 3's. Now we're replacing all the x's with 3 plus h. Like so. And now we're just going to simplify that because that looks horrible. Okay, so let's expand 3 plus h squared. So that's going to be 9 plus 6h plus h squared. And then let's multiply the 4 through the brackets. So plus 12 plus 4h plus 1. And then I'm just going to multiply the negative through. So negative 9 minus 6h minus h squared plus 12 plus 4h plus 1. And let's collect like terms and we're good. So I got a negative h squared. Took care of that. I got negative 6 plus 4. So negative 2h. And then I got negative 9 plus 12, which is 3, plus 1 is 4. Okay, so now I know I have a point at 3 plus h, comma, negative h squared minus 2h plus 4. So that's my x and y value of my second point. Looks horrible. Okay, so now let's sub it into this limit formula. So as h approaches 0, oh gosh, forgot the limit thing. So the limit as h approaches 0 of f of a plus h, which is this guy. So we got negative h squared minus 2h plus 4 minus f of a, which is 4, divided by h, because our x's, when we subtract our x's, 3 plus h minus 3, it ends up just giving us h on the denominator. Okay, so I got the limit as h approaches 0. So the problem is if I just shoved a 0 in for h, I would have a 0 in my denominator, which is not good. So we don't want to do that. So we want to just like simplify our equation as much as possible. So I noticed the plus 4 minus 4 is going to go away. So then I'm left with just negative h squared minus 2h divided by h. So I'm going to do what I did in the last question. I'm actually going to factor out an h on top. So I factor out an h, I'm left with negative h minus 2 divided by h. And I cancel out my h's. Limit as h approaches 0 of negative h take away 2. Well, as h gets closer and closer to 0, like if it actually was 0, then I would just be left with a negative 2. So it turns out as h approaches 0, this slope approaches negative 2. So we can say that the slope of the tangent at x equals 3 is negative 2. So we just proved that whatever that graph looks like, I mean, it's going to look something like this. I don't know exactly what it looks like, but something like that. When x equals 3, so say x equaled 3 right there, right at that point, we know that the slope is negative 2. So if you were to draw a tangent line, we know that the slope of that tangent line is negative 2. We could even write the equation of that tangent line if we wanted to. Because since you know, so if you actually wanted to write the equation of that straight line there, that red tangent, remember that's called a tangent line, you could actually write the equation of it. So it's y equals mx plus b. So we know that our slope is negative 2. We don't know our y-intercept. It's going to be something positive. We do know a point on our line is going to be that point right there, 3, 4. We know that because of we subbed 3 into the equation. So we could actually sub that in here. So 4 equals negative 2 times 3 plus b. And we got 4 plus 6 equals b. So our y-intercept's 10. So we know the equation of our tangent line is negative 2x plus 10, which is good. We might need that. So we know the equation of this line is negative 2x plus 10. And I just found that because we just found out the slope of it, negative 2. And I know a point on the line, 3, 4. Because that point is also a point on the parabola, but they share that point. So hopefully from this video, this is pretty crazy, but hopefully you're comfortable with seeing that you can use the average rate of change to approximate the instantaneous rate of change. And you can use this thing called limits to figure out instantaneous rate of change by making the interval between P and Q extremely small, almost nothing. And you can do that by picking points, like a point at this point 3, 4, and then picking a point like 3, 4, but we call it 3 plus h, and then figuring out what y is. Okay, I hope that made some sense.